Welcome back to the deep dive. Okay, today we're tackling something pretty mind-bending you've brought us, the quantum geometry of information model, QQM.
That's right. And crucially, it's not just theory. We're also looking at its executable protocol, the quantum printing process, or QPP.
Right, QPP. So our mission is to really unpack both. Let's dive straight in. What's the big idea behind QChamp?
Well, it's trying to solve that huge disconnect between general relativity and quantum field theory. But its approach is radical.
How so?
It says space-time, the metric math BFG we usually think of as fundamental. It's not.
Not fundamental. So what is?
Information. It proposes that space-time emerges from these basic units of information called a math BFI. Reality, geometry itself, it's all guided by information. It bubbles up from that.
Okay, wow. So if reality is information, then the QPP, this quantum printing process, is like the instruction set, the code to manipulate that information.
Exactly. It's a protocol for basically telling unrealized mass potential energy really how to collapse into a specific physical thing.
Like 3D printing, but with the universe's source code.
Yeah.
So for you listening, imagine specifying an object with information, math BFI, and then printing it into existence.
Precisely. But it requires immense control. That's the key challenge.
Right. The sources mention a core energetic requirement. Can you break that down?
Sure. You need an external control energy. They call it math BFE, which has to be delivered in a very specific way using something called the geometric control function, a math BFE.
And this energy needs to be what?
It has to be greater than the intrinsic energy needed for that bit of space-time to collapse its potential into mass. That's math BFE text collapse. So math BFE must be bigger than math BFE. Like, how do you even apply that kind of focused energy? What's the mechanism?
It relies on incredibly intense magnetic fields, very precisely shaped fields.
Magnetic fields? Why?
Because they can directly influence the fundamental unit spins, the math BFF values, of those information units, math BFA.
Ah, okay. So you use magnets to line up the information spins? Right, force them into coherence. And doing that temporarily changes the local information geometry, which is what allows the matter to print or collapse deterministically.
Okay, that's intricate. So if you're pumping in this control energy, math BFE, how do you know if it's actually working? Is there a metric for success?
Yes, absolutely. It's crucial. It's called the geometric coupling constant, kappa, or kappa.
Kappa.
And that tells you it's a dimensionless number between 0 and 1. It basically measures how efficiently your control mechanism, your magnetic fields, are translating that input energy into the required geometric change.
Efficiency. Got it. So what does kappa need to be for this whole QPP thing to even be possible? Is there a minimum threshold?
There is. For it to be operationally viable, you need kappa to be greater than 0.01. So between 0.01 and 1.
And if it's less than that, if kappa approaches 0?
Then it's game over. It means your control is so inefficient you'd need, theoretically, infinite energy math BFE to make anything happen.
Wow.
So, maximizing kappa is everything from an engineering standpoint.
Which brings us straight to the next big hurdle mentioned in the sources, entropy. Why is minimizing total entropy, math BFT, so critical for getting a good kappa?
Because any chaos, any disorder in the printing zone interferes directly with that delicate magnetic control you're trying to exert on the spins maps.
Makes sense. Control needs order.
Exactly. And total entropy math BFT has two parts they define. There's conceptual entropy, math BFH, which is basically physical disorder things moving around randomly.
Like heat.
Precisely. And then there's information entropy, math BFE, which is about the uncertainty in the information state itself. Is the blueprint clear and stable?
Okay, so two kinds of chaos to fight. Let's look at their low entropy protocol. How do you minimize the physical disorder, math BFH?
This requires some pretty extreme conditions. Mandatory cryogenic isolation. You have to run the process near absolute 0 temperature. Math BFT approaching 0 Kelvin. Any heat just scrambles the spins.
Wow. Okay, near absolute 0. What else?
We'll also need those strong, uniform magnetic fields we talked about, partly just to maintain spin coherence even at low temperatures. It pins everything down physically.
All right, that handles the physical mess.
Yeah.
But what about the information entropy, math BFL? Minimizing uncertainty in the blueprint sounds harder.
It is, arguably. It requires constant active stabilization of what they call the local space-time value, math BFL. You have to prevent random quantum fluctuations from messing with the target information.
So locking down the quantum fuzziness.
Sort of, yeah. And maybe the most critical part is active entanglement suppression.
Meaning you have to cut quantum connections.
You have to actively prevent the information units in your target zone from becoming entangled with anything outside that zone. Keep the information state pure, isolated, and definite.
This is incredibly complex.
But
it suggests QGIM isn't just philosophy. It's pointing toward a testable, predictive way to engineer reality, right? By controlling the information.
It absolutely is. It offers a potential path to manipulate the emergent structure of reality itself.
Yeah.
But that power comes with a very stark warning built into the model itself.
Oh, what's that?
It's what the sources call the irreversible loss warning. Because consciousness, self-awareness, seems tied to the specific instance of an information state.
Uh-oh, where's this going?
The implication of QGIM and QPP is profound. No conscious information state, no person, no mind can ever be perfectly copied, replicated, or restored if that original instance is lost. The integrity is unique to the instance.
So, no backups for consciousness.
Essentially, yes. And that ethical boundary, that fundamental limit derived from the physics itself, has to be the absolute guide for any future work in this area. It's a built-in stop sign.
A chilling but vital takeaway. Something for all of us to think about long after this dive.